All right, good morning. How's everyone doing?
Doing very well, thank you.
Good, awesome.
How are you?
Doing okay.
Sleeping.
Yeah, I
Yeah.
can relate to that. All right, any questions? All right, so announcement, I will not have office hours this coming Monday morning. I've canceled those on the schedule page already, but wanted to mention it in here. I won't be in office Monday morning, and I had planned to meet one person, so I will talk to you directly. But let's see. So I posted an announcement yesterday on Canvas relating to the ODP and the homework and some business of moving around directories, and hopefully everybody saw that. I think in some cases it helped. Um, but let's talk about the ODP and the homework. So the homework, first of all, if you did not finish homework 2, you got to come to office hours and we got to figure this out because homework 2 is the way that you're going to submit everything in this class other than ODPs and your midterm and your finals. So you got to get your Git setup squared away. Um, so that's the first thing, and I only had like 2 people come in this morning for help. So either people have figured it out or something else is going on. But make sure that even though homework 2 was due at 8 this morning, make sure that you've got a complete solution for that, including sending me your GitLab ID and email. Okay, so that's super important. Um,
I was really confused by the warning message it gives you at first. It doesn't. You can't make a secure connection to this IP. Do you want to continue? And you should just hit yes.
right. Yeah, so that's disconcerting when you first encounter it. Um, that's something that's going to pop up now and then in doing any kind of attempt to securely authenticate um, between systems. And here's the basic problem, right? Let's say that you and your friend want to set up some way to let yourselves know if one of you is an imposter, right? So I lost my cell phone. Well, my cell phone got stolen a number of years ago, and I needed somebody else to give me some information. And they're like, "How do I know that it's really you?" Right? So I had to come up with something that only I would know. So you can set that up, and that's basically what you're setting up with GitLab, for example, when you set up an SSH key. But the question is, the first time that you do that, how does it know that you're who you say you are? If I call my friend up and I say, "Hey, if you ever want to know that it's me, just ask me this question and here's the answer." Well, that's great, except if at that moment I'm impersonating me, right? And so that's what that warning is when you first try to connect to GitLab or to a remote machine using a public-private key pair. It says, "Hey, there's no way to authenticate that this is actually you. Do you trust this?" Right? And so we have to take the default there and say yes. But you want to do that, when you're sure that this is what's actually going on and somebody hasn't spoofed the GitLab address and is pretending to be GitLab.com. So yeah, that's a little bit strange. All right, so what I want to do today is talk about some more bash that you're going to need to do ODP 403 and that you'll need to do your first programming assignment PA1. And then I want to go through PA1 in a fair amount of detail and give you enough so that you can start working on that over the weekend. Let me make 2 general comments though. First of all, Wednesday when we talked about homework 2, I think you remember me saying, right, work on this today so that if you run into problems, you can come to office hours Thursday morning, right? And the majority of people did not seem to do that because I had a lot of people coming through email yesterday who seemed to be just starting homework 2 on Thursday, right? The reason I said to start it on Wednesday is because, Friday morning office hours are after the deadline. And so, in general, in this course, whenever you have an assignment, right, you want to work on it soon enough so that if you run into troubles, you can come to office hours and get help. Going forward, I'm not going to answer questions in email about, problems with code, problems with submitting code, problems with Git, things like that. Okay, I'm going to restrict that to office hours from this point forward. Homework 2, I made an exception because that one we've really got to get nailed down. And also, the ODP, that was the first ODP where you were writing your own code. Okay, so I went ahead and offered help with that. But going forward, I'm going to restrict it to office hours, right? All right, so let's see. Let's talk about ODP 403 first. And so this involves command line arguments.
Quick question.
Yeah, go for it.
How do you, on putty, increase the font size of your Linux window?
Actually, that's a good thing to talk about too. Let's take a side trip into putty. So, because a lot of people will use putty, and let me bring up a window. So putty is highly customizable, right? So if you get to your putty configuration window, you can put in your username, linuxengrcs.com. You can go to Window and set your scroll back. It's normally something really mild, like 999 lines or something like that. Make your scroll back as big as you can so that you can go back and see previous work you've done. And then under Appearance, you can change your font size, and you can change your font as well. You can make it bold-faced and so on and so forth. And then under Colors, you can change your foreground, background color, and so on and so forth. After you've got this set up just the way you want, come back to Session, and you can either name this session or you can type in default settings and hit Save. And it will save everything that you've configured under, either another session name or a default setting. And then next time that you run putty, if you change your defaults, it'll automatically have all of those configuration options set up.
Can you remind me, what are we supposed to be using putty for?
You don't have to, but when you want to connect to the Linux machine, linux.engrcs.com, you need to use some kind of program to connect to that, right? Because that's a remote machine. So if you're on Windows, typically people use putty. If you're on Mac or Linux, you can use SSH, but you can use kind of anything that you want.
Using the Mac terminal.
Okay, yeah, so you can just SSH in.
SSH in from PowerShell.
You should be able to. SSH should work from there, as far as I know.
That's what I'm doing.
Yeah. Pretty.
Just had one quick question.
Mm-hmm.
I didn't get the ODP to submit to the proper method. I sent the email to you last night. Am I still going to get any grade for that, or is that just a 0 for not submitting it the proper way?
Did you come by office hours? I don't think I saw you in office hours.
No, I was busy all day yesterday.
But I mean this morning at 8:30.
Oh, no, I even slept through my alarm.
Okay. So yeah, so those I don't go back and change grades and such, but make sure that you know how to do the ODP, because ODP 403 is a minor variation on that. And 403 is open right now. That's open till 8 o'clock tomorrow morning. So you can I'll show you how to assess 403 today, and we can go from there. And I can show you the code for 402, and then you can work from that. Let's see, I thought assess command is how we submit. Do we do anything past that? Nope, that's all you got to do for the ODPs is just the assess command.
Also for the ODP, does it matter if it's in the CSE224 directory or?
No, it doesn't. So the ODPs do not have to go into Git. They don't have to get pushed to GitLab. They don't have to be named anything in particular. The only thing you have to do to get credit for the ODP is run the assess command use the G option and make sure it gives you 10 out of 10 on each test. And if you do that, you should be good to go.
I opened up my Putty right now. What tab is the, I think it was like scroll back on? I was skimming through and I can't find that option.
Oh, let me see. I think it's under window. So yeah, click on window.
There we go.
Cool.
Thank you.
Yeah.
Hey, could I ask you a question real quick?
Sure.
Reviewing yesterday's code, it was, you did cp/bin/bash. What did that do again?
So I was making a copy of a file from one directory to another. So the cp command lets us say copy space some source file space some destination file. So what I was doing at that point was showing that bash is just a program. In this case, it's a program stored in a file in the directory /bin, and the file is called bash. And I think I copied that to like haha or something. That created a new file in my current directory named haha with the exact same contents as this file. And if I just run this file, it's the same thing as running bash. So that was just an example of the fact that bash is a big executable program.
Oh, gotcha. Thank you.
Yeah.
Is there anything we can denote our bash scripts with? Because I noticed yesterday in class when we did the homework that you weren't supposed to like give it a dot something.
You can. It's not unusual to, name your scripts something.sh, for example. That's fairly common, but it's completely arbitrary. It's just a convention. It has no particular meaning from the command line. I could call it .c and put bash code in it. It would be a little strange to do, but that's totally legal too. So usually for scripts, what I do, I don't bother putting in an extension. But yeah, you can put in sh or whatever. Just make sure if you call it odp402.sh that when you assess, you say assess odp402.sh, odp402.sh.
Okay, thank you.
Yeah, you're welcome. Let's see, what's the command I can use to read the README? So the README is under /temp. So if you're logged into the Linux machine, you can say cat/tmp/readme-403 for the latest one, for example. Welcome. All right, send me an attendance note. Let me know that you're here. And let's talk about command line arguments. So ODP 402, you wrote a script which let the person, once they ran the script, they typed in something and then the script printed out 2 times what they had typed in. So, you say ODP 402 and you hit enter. And once you hit enter, the program is running, and the program is sitting there blinking, right, waiting for you to type something. And so you type the number 12 and you hit enter, and then the program prints out 24. Okay, when you supply program input like this, when you run the program and while it's running you type in stuff, I'm going to call that something like runtime input. Right? It's information that you're giving to the program while it's running. But there is a second way that we can give information to a program, and that's to use what's called a command line argument. And this is super important, right? Most things that we do in this course, most of the assignments are going to talk about command line arguments or runtime inputs. And you got to be clear on what the difference is. Okay, it's a really needless way to lose a lot of points if you get these confused with each other. So a runtime input means while your program is running, you type something in. Okay, what's an example of a runtime input? Well, in Unix, there's a command called BC. It's a calculator, right? So I say BC and I hit enter, and I want to know what 2 plus 3 is. So I type 2 plus 3 and it tells me 5. And I want to type, 23 times some other number, and I hit enter and it tells me what that is, right? These are runtime inputs. These are things that I'm putting in while the program is running. There's a totally different way we can specify information to a program, and that's using a command line argument. And when we want to make a command line argument, what we would do is we would say, something like ODP 403 space 12, and then we'd hit enter. In other words, while we're saying what program we want to run, we're also saying what the input to that program is. So if I say ODP 403 space 12 and I hit enter, that's a command line argument. Okay, the command line is just, the line that you're typing a command on. And what's an example of a command line argument? Well, for example, every time you use VI, if I say, VI haha, I'm telling VI what program I want it to edit. Right? I'm doing two things for once. I'm specifying the command, but I'm also specifying an argument. So I say VI haha, and now I'm editing this file. Control D will also get you out of that runtime calculator. All right. So everybody see the difference between these? Yeah, go ahead.
There was a quiz, I believe,
Mm-hmm.
and one of the programs, I guess, I don't know if I can even say this. Is the quiz over?
Which quiz?
Like the first one I had to take?
Homework 1?
There's one where you have to paste C commands into.
No, we haven't really gotten to that yet.
Well, anyways, okay, I guess I can't ask the question.
Yeah, if you got spoilers, let's talk about it offline. Oh yeah, homework 3.
Actually, could you paraphrase, kind of summarize the difference between those again real quick? I was busy trying to get out of that calculator.
Okay. Runtime input, you're running your program, and while it's running, you're putting in information. Right? So your program is running and it's saying, hey, give me a number, give me a command, give me this or that, right? A command line argument, on the same line where you're typing the command you want to execute, you're also typing one or more pieces of information to give to that program. Okay, that's a command line argument. And they're very different ways of interacting with a program. So what would VI be like with a runtime input? You would type VI enter, and it would say, what program would you like to edit? And you'd say, ODP 403 enter, and then it would edit. Kind of a pain, right? So command line arguments, let me say, hey, here's a command I want to run, here's the argument I want to give to it. Okay? And your whole goal for ODP 403 is to do the same thing you did for 402, but instead of getting a number from the user while the program is running, you get a command line argument. All right, so what does this look like? So ODP 403. So ODP 403, write a bash script that expects a single command line argument, which you can assume is an integer, and prints twice its value. Name your script ODP 403 and assess it using the command assess ODP 403, ODP 403. Again, make sure it doesn't do anything except print twice the value. And a lot of people got caught up with this. In fact, so yesterday I had like 60 emails from students. I was chatting with students till 9:30 at night. Almost every question that came and every answer that I gave was something that was in the assignment or in the lecture or in the how-to guide, right? And the lesson here is that computer science is probably the pickiest of all subjects, right? Pickier than math, pickier than medicine, pickier than most anything that you could do in college, right? Chemistry, you do some big experiment and you take some reading and you're asked to calculate the mass of this thing, right? And you can be off by a little bit and still get the correct answer, right? Computer science, right? You miss one period, you miss one semicolon, you put a minus sign instead of a plus sign, and planes fall out of the sky, right? I mean, literally. It is such a picky discipline, right? Because computers are so unintelligent and unforgiving, right? They don't interpret what you mean, they just do exactly what you tell them. And so every little detail can be super critical. And the tricky part is, if I give you a 6-page how-to, right? Can you follow every single piece of detail in there? It's really hard to do, right? And so assignment prompts and things like that, I'll try to keep them as close to, the bare minimum as possible, but it's hard to do. And one of the challenges is, if you read the instructions for doing something and you try to do it, you might do that 10 times and be positive you're following the instructions exactly, but be making the same mistake each time, right? This is how our minds work, right? We don't always see the thing we're looking at. Sometimes we see what we think we're looking at, right? Which is what we're doing instead of what we wanted to do. It's really, really tricky. And one of the hardest parts of computer science is sort of rewiring these parts of our brain that are so kind of habit-based and getting to a point where we can actually see things new that we've looked at a bunch of times already. And this is a common challenge, right? If you've written an essay and then tried to proofread it, and you proofread it really carefully, you turn it in, you get it back, and there's all sorts of mistakes in there, right? Because when you proofread something that you've spent 2 hours writing, it's very hard to actually see the words that you've written. What you're seeing is what you thought you were writing. Okay? And this pops up in programming when we try to find bugs in programs. You write a program and you say, okay, I'm going to do this loop, and when this condition is true, I'm going to do this other thing. And no matter how long you stare at your code, you're not seeing the little mistake that you made in there. You're seeing what you wanted the code to do. And so it looks like there's no mistake. So if this is frustrating, you're in really good company. Okay? It's like I say, probably one of the most challenging aspects of doing computer science. Is that it's so picky and it's so hard sometimes to be able to look at things with fresh eyes. And so this is where you'll find advice about stepping away, go take a walk, or stare out a window or something, to reset your brain so that the next time you come and you look at your code or you try to follow some instructions or whatever, you can more successfully be doing that instead of just repeating what you did the last time. So don't worry if that seems challenging, right? It's challenging for everybody. I still struggle with it when I'm doing something new, but it gets easier over time, right? But you got to kind of believe, if I do this and that's supposed to happen, well, I did this, but that did not happen. You got to believe that the universe still works the way it's supposed to. And there must be something different that I did from what I think I did. It's possible I messed up, though, right? It's possible that I might give some instructions to do something and something different happens from what I said would happen, right? But if that's the case, everybody's going to notice this, and everyone's going to jump up on me, and I'll probably post something, or make an announcement somewhere and say, hey, my bad. So for what that's worth, I just wanted to mention that. All right, so ODP 403, take a command line argument, print out twice its value, don't print anything else. All right, so what does this look like? ODP 403, if I just run that, I get an error, right? I need to say ODP 403 space followed by a number. So I could put in a number like, 15. It prints out a 30, and that's it. All right, and you can assume that the number is an integer, so don't worry if the person does something funny like this, right? You're not responsible for what happens in that case. You're only supposed to write a script that lets me take in a number, prints out twice that number. And we'll talk about how to do that next. But questions so far? And then to assess your program, just say assess the name of your program twice. And all the lessons from ODP 402, right? Make sure your script is executable, use a change mode instruction, etc., etc.
Now, is this a kind of bash, or?
This will be done in bash, right? So this is a bash script. And we got to talk about how to pick up command line arguments, but that's our next topic. Alright, so how do we read command line arguments in bash? It's super easy. It's a lot easier than it is in C. So let me make a script called try. I'm not going to include stdio.h. I'm going to do bin bash. So if we have one command line argument and we want to do something with that, it's just $1. Right? So remember, $x would give us the value of a variable named x. $name gives us the value of a variable named name. $1 gives us the value of whatever this first command line argument is. $2 would give us the value of a second command line argument if there was one. And so on and so forth. So I'm going to set x equal to $1. And then I'm just going to print it out in an echo statement. The argument was $x. Make it executable. So if I say try 56, it tells me the argument was 56. If I say try this is a test, it tells me the argument was this. That was the first thing that I put on the command line after the name of the program. If I don't put anything on the command line, then that argument is blank. So the argument was, and there's nothing there. So the only difference between ODP 402 and ODP 403 is instead of using a read command to get input from a user, you're just going to use $1. $2 would be a second command line argument. So let's try that. Let's look at $2. So if I just say try 12, the first argument is 12, the second argument was nothing. If I try hello world, the first argument was hello, the second argument was world. And this is an example of what's called junk code, right? It's code that we just write to experiment, just to play around with things. And while we're in here, there's another variable called $number. $number tells you how many things are on the command line. So if I say try hello world, $number is 2. If I try hello world, ha ha ha, $number is 3. If I just say try with 0 command line arguments, $number is 0. So these special variables let us interact with command line arguments.
sign number again?
$ number tells you how many command line arguments you have. So if you run a command and you put 3 arguments, and arguments are things separated by spaces. So if I have 3 things separated by spaces, $ number will be equal to 3. So here's an example of ODP 402, and most people got here in the end, right? So read an argument and then echo 2 times that argument. So modify that for ODP 403 so that instead of typing in your number while the program's running, you just say ODP 403 and you put the number on the command line and it prints out twice that number.
Why are there 2 shebangs in your ODP 402? Am I supposed to be having 2 shebangs?
No, that's just a style points thing. The only time that number sign means anything other than a comment is in the very first line, and if it's a number sign exclamation mark. But I don't know, somewhere when I started doing bash, I saw this and I kind of liked it, so I just do that. But it doesn't mean anything.
Technically, you don't even need a shebang for what we're doing, really. Just good practice.
I think assess is using bash, so I think you're okay. But that could change.
So you're saying if we want to be cool, we should include the other shebang.
Or you should come up with your own and be like super cool. Code is fingerprintable. As people do more coding, they start to develop styles. It's like handwriting. You can look at someone's handwriting and tell who wrote it. Code is the same way. You can just sort of see like styles that people develop, and it makes it more fun, right? If you're kind of doing your own thing. All right, so that's all you need for ODP 403, right? So just change 402, have it do that output, and then to assess, just assess ODP 403, ODP 403, use the grade command. Hey, I got 10 out of 10 3 times. I'm good to go. All right, any other, make sure you use change mode. So change mode 755, and then whatever your code is.
If I use the copy command, the file that I'm copying and the first argument will still be there after I do the copy, right?
Correct, yeah. So copy reads source and destination. So copy from to, and this file should not be disturbed. You just get a copy of it. But if you want to actually rename a file, you can say move from to. Well, that basically gets rid of this file and replaces it with this file instead, right? It changes the name of this file from to. But this just makes a second copy of the file. Any questions on directories? I posted some words in Canvas yesterday in an announcement about the whole kind of question of directories, moving around directories, and so on and so forth. I kind of thought that was done in 121, but I'm hearing from some people maybe it's not covered in there. But you know, basically when you log in, you're sitting in some home directory, which is /home/your name. And when you're playing around with your SSH keys, right, you do a CD to .ssh so that you can look at your public key and so on. If you do pwd, you'll see you're not in your home directory anymore, you're in a subdirectory. Right? If I want to make a CSE224 under my home directory, go back home by just saying CD. That moves me to my home directory again. And then I can change into CSE224. And pwd is always a good way to know where you are, right? So I'm in CSE224. And maybe I want to put all of my ODPs into one subfolder under this, so I could say make dir ODP work. Right, now I'm still in my CSE224, but I could say change into ODP work. And now I'm in a new subdirectory under my home directory, under 224, under ODP work. And I don't have any files in here yet. but I could copy. Yeah, go ahead.
You don't have like normally when you're in a shell, it shows your location and then a $sign or something like that.
Mm-hmm.
But it looks like you just have like.
I just have a number.
Commands you inputted.
Yeah. That's just me being weird.
Okay.
A lot of shells by default will show your directory, and then you don't have to keep saying pwd. But I kind of like to know that my prompt is always sitting right here, I guess, instead of over here or over here if I'm in a deeper subdirectory or something like that. It's just individual preference. And you can copy files, right? So tilde also means your home directory. So I could copy my ODP 403 from my home directory into my current directory, and dot means my current directory. So if I do that, now I've got ODP 403 sitting in my ODP work directory. And I could have moved that file with an MV command instead of making another copy, and so on and so forth. So go through that announcement and look at the how-to. It gives you a synopsis of CD and PWD and stuff like that, and try to find a file system organization that you're comfortable with, because it gets really confusing if you have a bunch of files in one place, or you've tried to start this project in 3 different directories. Right, that's a recipe for disaster, because you start working over in this directory and you make some changes, you go get lunch, you come back, and you start working in this other directory, and now you've got 2 copies of your code that are different and all kinds of stuff like that. So try to organize your work in a way that makes sense to you. All right. Okay, let's talk about PA1. And hey, ODP 403 done. Good deal. Let's talk about programming assignment 1. So this is your first longer term programming assignment. This is due a week from today. And it's a bash script. And it's a bash script that plays a little game. It's a stick picking game. So I don't know if you've ever done this, but you have a pile of sticks, right? And it's played by 2 people. And the rule is you take turns picking sticks, and you get to pick 1, 2, or 3 sticks from the pile. And you win by taking the last stick. All right, so I think.
Yeah, that's it.
Okay, good. There's 2 ways to do it. All right, so you're going to write a bash script that basically plays this game with you. So let me show you what this would look like. So here's the game stick. And it says, welcome to my matchstick game. How many sticks would you like to play with? Let's play with 20 sticks. Okay, and then it says, who should go first, the user or the computer? I'll let the computer go first. So the computer takes, so it shows me the initial pile of sticks. There's 20 sticks, right? And the computer takes 1 stick. And so now there's 19 sticks in the pile. How many sticks would you like to take? Well, I'll take 1 stick also. So now there's 18. The computer says, I take 2 sticks. Now there's 16. I'll take 3. That leaves 13. There's 12 after the computer takes 1 stick. How many should I take? I'll take 2. That leaves 10 sticks. The computer takes 2 sticks. Now there's 8. I'll go ahead and take 1 stick. That left 7. The computer took 3 sticks. Now there's 4 left in the pile. How many should I take? And I think I just lost the game. So I'll take 2 sticks. That left 2. The computer takes 2. The remaining pile is empty. It says, I win. Yay. All right. That's PA1. If you're good and you go first, or you start with the right number of sticks and let the computer go first, you can win. But you're going to write this script so that the computer uses a very particular algorithm in choosing how many sticks to take, so that in most cases, if the user doesn't know what they're doing, the computer will be able to win the game. All right, so that's the basic behavior of the program, right? Say stick, it'll ask how many sticks you want to play with, tell it how many you want, we'll play with 17 sticks, tell it who should go first, and then just take turns picking sticks, show the pile after each turn, and so on. So there's details here, right? If the user makes an illegal move twice in a row, kick them out, right? You're supposed to take between 1 and 3 sticks. I tried to take 4, I tried to take 12. It said you're cheating, you're out of here. All right, if I make one attempt at an illegal move, but then I go back and I play by the rules, all is forgiven, okay? If I make another attempt at an illegal move, right, I get one more try. It says that's cheating, try again. Okay, I'll make a legal move, I'm good to go. How many sticks should you take? Ha ha ha, right? That's not a legal move. Give me another try. But at any point, if I make 2 illegal moves in a row, that's grounds for disqualification. All right, so illegal moves, right? When the user is asked to make a move, they must enter 1, 2, or 3. If their entry is illegal, remind them of the options, ask once more. If they make another illegal move, game is forfeit, they lose. The other thing is when you start the game and you say, how many sticks would you like to play with? If they don't give you a valid answer, keep asking. Don't give up on them. I want to play with 1. Okay, I'll play with 2. I'll play with 3. I'll play with ha-ha. Okay? Keep asking them until they give you a legal number. And then, who should go first, user or computer? If they don't give you a legal answer, keep asking until they give you either a U or a C. All right? So this is one of these points where the details are super critical, right? Because I'm going to test your code exactly like this. I'm going to make sure that I can put in a bad number of sticks and I can put in a bad answer to this multiple times. And I'm going to make sure that if I put in an illegal move twice in a row, you kick me out. All right, so that's what's going on up here. The algorithm is really straightforward. When the computer is choosing how many sticks to take, look at the number of sticks left mod 4. Okay, there's a modulus operator, it's a percent. Look at the number of sticks mod 4, that's how many sticks you should take. The one detail is when you pick a number mod 4, you could get a 3, a 2, a 1, or a 0, and 0 is not a legal move. So if the number of sticks left mod 4 is equal to 0, the computer should pick 1 stick. All right, other requirements. It's got to be a bash script. Make sure you back up your work on the way. I recommend pushing this into Git as you work so that you have backups there. You got to comment your script. Okay, number sign begins a comment. You should have a block of comments in the beginning of your script, including your name, the course, CSE224, the date, the assignment number, programming assignment 1, and a synopsis in your own words of what this script does. Okay, big block of comments, 20, 30 lines would be fine, right? That have this information in there and basically says what's going on. And then comment your code as you're writing it, right? When you do something like, you know, x equals $paren, n parentheses, n %for, close paren, put a comment on there. Tell the person reading your code what the heck that statement does. Why is that there? Right? Why are you taking n mod 4? What is n? What is x? Why mod 4? Right? So document your code as you write. A big part of this whole CS sequence is going to be getting you in the habit of doing good commenting of your code.
I thought I was tired at the start of this, now I'm more tired at the thought of doing PA1.
Sorry, say again?
I thought I was tired at the beginning of this, now I'm more tired by the thought of doing PA1.
Oh, but PA1 is fun once you get it done. it's a program you can show to your friends who aren't computer science students, and they can still appreciate what it does, you know. And it's a fun one to grade because they get to spend the whole weekend playing stick against a computer, you know. So it's.
You actually go through every one?
Oh yeah, totally, yeah.
That's awesome.
Yeah, and there was some discussion in Discord yesterday talking about you know, how people tried to make ODP 402 nicer by you know, making it more conversational, or you know, having the cow speak your answer by using the cow say command. And assess just kind of, you know, gives you a frowny face and says 0, right? Assess has no sense of humor, has no interest in creative expression. But the programming assignments, I grade those myself, right? And so as long as you make sure you do what the assignment asks, you're welcome to be creative and add, you know, bells and whistles, and sort of explore how you want to create your user experience within reason, right? If you know, decide to display your output 1 character per second like an old typewriter, that's really cool, but it's not so good when I'm trying to grade, you know, 60 programs. But, you know, other than things like that, feel free to you know, stylize things the way you like, right? That's always good. And that's part of the fun of programming, actually.
I have a question.
Yeah.
I put sleep commands in mine to make it feel a little more less instant and more human.
Yeah,
That's fine.
that's the only other one that I'd rather you didn't do. Again, just because in terms of efficiency. And if I find those, I usually just go in and sort of comment them out so that I can test, because I'll probably run each program, you know, 5 or 10 times, and the first time I run it, you know, I'll look carefully at the introduction, make sure that you're telling the person what to do, and so on and so forth. But then I want to kind of scoot past that and get into the actual gameplay. So one thing you could do, though, is you could have a switch on your program. Like if you say stick space, you know, human, then it would go ahead and it would do those sleep statements to make it, you know, more conversational for a human, something like that. So that's an example of a way to embellish the code without changing the core functionality.
What is the sleep command?
Sleep just takes a break. So if you say sleep 5, it'll hang out for 5 seconds, and then the command exits. So if you've got a bunch of output to show the user, it's nice to sort of show it, you know, maybe 1 line and sleep for a few seconds, show the next line, and so on and so forth. Same thing with clearing the screen. Sometimes it's helpful to clear the screen and then show the user some information. That makes it a little harder to grade because, you know, a lot of times I want to go back and see what was previously displayed, and clear will get rid of that, and so on. So it's a bit of a compromise. All right, on Canvas you'll find a bash how-to summary of bash, ifs, loops, and arithmetic. And we're not going to have time to get through conditionals and looping today, but this should explain it pretty well, right? Let me just tell you, though, that this is another case where syntax is super critical. So if you want to make a while loop, you say while space, bracket, bracket, space, some condition, space, bracket, bracket. Next line you say do, next lines you say what you want to do in that loop, and then you say done. Alright, and the things you can put in there, if you want to compare strings, you can say quote, 1 string, space, equal, space, and then another string. If you want to compare numbers, you can say, you know, first number, or, you know, variable, space, dash EQ, space, second one. Right? But these spaces are really important. In C, they don't matter. In Bash, they make or break it work. So if space, so while space, bracket, bracket, space, 7 space, dash GT, space, etc., right? So you can use those as conditional statements inside while loops. And then you can also use those in if statements. So an if statement is if space, bracket, bracket, space, and then some condition, space, bracket, bracket, new line, then, new lines, the things you want to do in your if statement, new line fi. That's the end of your if statement. That's the closing curly bracket, if you like. And for an if then else, it looks the same except you have an else. And for an if else some other if condition, the keyword is elif.
Is there a greater than equal to or less than equal to operator?
So for numbers, you can do GE or GT for greater than or equal to, greater than, less than or equal to. So I would suggest take this guide and just write some practice shell scripts. Write an if statement that reads something from the user, and if it's equal to something, do one thing, otherwise do a different thing, right? Play around with ifs, get used to writing these if statements, and then same with loops. Just write some while loops. Write something that you know, gets a number from the user, and while it's not equal to such and such, do something. Do you know if the engineering building is open? I think it is. I think you still have to do a health screening, which I think you can do online, or you can do it at the main entrance to the STEM building. But I think the building is open in general for people to come in and use the study areas and so on. I have not been in the building in, you know, over a year, so I don't know how that works. Is it open? Okay, good. All right, so play around with this on your own, and Monday we will start going through some of this in detail, and that should be everything you need for PA1. So I would try to get started on that, at least the parts that involve things we've already gone over, and we'll go through these in detail on Monday. All right, have a good one. I'll see you in 2:15, or I'll see you next week.
Thank you.
Thank you.
See you at 2:15.
All right. I'm not going to do an attendance ping at the end here, so you're already good if you pinged me in the beginning.
You said you won't have office hours on Monday, but it'll be normal the rest of the week?
Yeah, it's just Monday. I've got a dentist appointment in the morning, so.
Okay, thank you.
All right.
Good luck.
Thanks. Have a good one.
Nick, real quick, in the future, are we going to be able to write programs in RPAs and C if we want, or is it all going to be bash from here?
It's going to be a mix. So PA2 will actually be the same stick program with a few changes, but written in C. And we'll kind of ping back and forth between C and bash.
Sounds good. All right,
Cool.
have a good one.
All right,
So
see ya.
you said you're not doing anything other than office hours anymore?
You can send me an email, but there's a good chance, unless it's something that needs to be addressed in email, there's a good chance I'll say, let's talk about this in office hours.
Okay. Well, I just have a question, because I'm trying to work on ODP 3 right now.
Okay.
And I'm not sure quite what I'm doing wrong. Do you mind if I just share my screen?
I got to get to my next class, unfortunately.
Oh, okay.
Go ahead. There's still a few other people connected, but go ahead and share if you want. I can take like a look for 1 minute.
Okay.
Let me make you a co-host. All right, go for it.